Y'all, it's Becca. I'm a math, physics, and astronomy tutor here at Chegg. If you ever need such a tutor, feel free to check out my profile, which is linked below. But today I'm going to talk to y'all about addition of vectors. Now, suppose we have these three different vectors, vector being something with both magnitude and direction. Your first vector has a magnitude of 5, and it is pointed straight along the positive y-axis. Your second vector is magnitude 3, and it points straight along the negative x-axis. And your third vector has a magnitude of 10, but it is oriented 30 degrees below the positive x-axis. Now, how do we add those three vectors together? It is a pretty strong temptation just to add the magnitudes of the vectors and call it a day, since the net vector, big V, is equal to V1 plus V2 plus V3. But unfortunately, that's not going to be the case because direction is very important when we're talking about vectors. It is one component of vectors that makes it a vector. So what I like to do when I'm adding vectors is I like to break them down into x and y components. These are two-dimensional vectors here. So we have two components to each vector, an x component and a y component. And I like to do that using this vector notation or this matrix notation, whatever you prefer. And I write my x component up here and my y component down here. Now, considering vector 1, it is not at all pointed along the x-axis. It is a completely vertical vector. So it doesn't have an x component. So in that case, we can simply write 0. The entirety of vector 1 is pointed along the positive y-axis. So its y component is simply positive 5. Okay? Now we can do a similar thing with vector 2, except in this case, this is a completely horizontal vector. So that means it points completely along the x-axis in some direction. It does not have any vertical component whatsoever. So what we can do is we can put 0 down for our v2y. But our v2x lies entirely along the x-axis in the negative direction. So we have to take that negative into account. So our x component for the second vector would be negative 3. So that means 3 pointed along the negative x-axis. Okay? Now v3 is where things start to get just a little bit more complicated. It does have two components, but they're not necessarily quite as v1 and v2. So let's see if we can figure those out. The way we do that is we construct a triangle. We have a triangle leg here, and we have a triangle leg. And this component right here would be our x component of the third vector. And this right here would be our y component, pointing along the negative y direction and the positive x direction because we are here in quadrant 4. Okay, so in order to do what we've done previously with the other vectors, we need to use a little bit of trigonometry. This is where you dig out your info on SOHCAHTOA. Recall that the sine of an angle is equal to the opposite over the hypotenuse. The cosine of the angle is equal to the adjacent over the hypotenuse. And those are the two functions that we're going to find useful here because we know what the hypotenuse is. It's the magnitude of this vector here, which is 10, right? Because v3 is 10. So let's figure out what the sine of 30 will give us. The sine of 30 degrees is equal to the opposite v3y divided by the hypotenuse, which is 10. So if we solve for v3y, all we have to do is multiply both sides by 10, and we know then that v3y is given by 10 times the sine of 30. Okay? Now this is going to be a very similar thing for the cosine of 30. But instead of looking at v3y, we're going to get an idea of what v3x is. So the cosine of 30 is the adjacent leg, which is v3x, divided by the hypotenuse, which of course is 10. So solving for v3x, we multiply both sides by 10 and find that v3x is 10 times the cosine of 30 degrees. Now, when you are popping these things into the calculator, or if you have your unit circle memorized, it's even better. But it's not always going to be a nice angle like 30 all the time. So if we have 10 times the cosine of 30, that gives us roughly 8.66 in the x direction. Remember, this is the positive x direction, so we can leave that positive. And 10 times the sine of 30 is 1/2, so that gives us 5, but it's going to be 5 here in the negative domain of y, so we need a negative 5 here. Okay, so now we have these vectors split up into components. We can properly add them. So what we can do is we can recognize that adding these vectors is the same thing as adding their x components together and adding their y components together. And that will give us the components of the total vector from which we can find the magnitude. So let's look back. Our x component of our first vector is 0. Our x component of our second vector is -3, and our x component of our third is 8.66. So we have 0 minus 3 plus 8.6. Okay? So that'll give us our total x component of the net vector, v. Just call it big, capital V. So 8.66 minus 3 gives us 5.66 in the positive x direction. Okay, so let's look back. Our y component for our first vector is 5, 0 for our second, and -5 for our third. So what happens is our y component is actually completely canceled out. And our net vector lies entirely along the positive x-axis. Now, generally, you can use the Pythagorean theorem of the vector, meaning the x squared component plus the y squared component, take the square root, and that would be the magnitude of the vector. But in this case, we have a completely horizontal vector, and we know that its magnitude has to be 5.66 because it doesn't have a vertical component at all. So our final vector will be, let's see, be about there. So draw a little arrow. That is our net vector between these three vectors here. And its magnitude is 5.66 in the positive x direction because we had a positive x component for our net vector. All right, so hopefully that helps give you the building blocks on how to add vectors algebraically. This is just one example. There are countless examples of ways to add vectors in 2 dimensions and 3 dimensions and so on. If you ever need help adding vectors, feel free to hit me up or any other math or physics tutor here on Chegg. Okay? Bye.